Welcome, geniuses. I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Right, so under this chapter of physical quantities and units, first we're going to learn about what is a physical quantity. So what's the definition of a physical quantity?
Quantities that can be measured.
Okay, some people say it's quantity that can be measured, but the full definition is a physical quantity that has a numerical magnitude and a unit. Example, you give me any quantity in physics, right? You give me any quantity. Let's say force. You can give me the magnitude and you give me the unit, right? Like 5 Newton. So that is a physical quantity. In fact, any quantity in physics is a physical quantity. Okay? Because it has a numerical magnitude and it has a unit. But we can further subdivide it into two categories. We can call it base quantity and derived quantities. So what is a base quantity? The definition of base quantity is quantities that cannot be expressed in terms of other physical quantities. That means base quantities are by themselves. You cannot express in terms of other quantities. And there are altogether 7 of them here. And in your syllabus, you only require to know 6. For example, let's talk about length. Can you express length in terms of another quantity? Length is length. Or time? Time is time. But if you're talking about derived quantities, which is the second one, the derived quantity, you obtain it from other base quantities or other quantities. Example, speed. The definition of speed is total distance traveled per unit time. So you're taking distance divided by time. So you can express in terms of other quantities. Then it's not base. Base means you cannot express in terms of other quantities. So what you need to remember is all these 6 quantities: length, time, mass, current, amount of substance, and temperature. And their base SI unit, which is meter, seconds, kilogram, ampere, mole, and Kelvin. Because if I don't tell you, people sometimes take the length as centimeter. No, it's meter. SI unit is meter. SI unit for mass is kg, not gram. SI unit for temperature is Kelvin, not degrees Celsius. Do you understand? Alright, so you must remember all this. So why must you know all these? Units here, especially the SI unit symbol? Because we're going to learn homogeneity a bit later of physical equations, and then you will have to convert any unit that you have into this form. Example would be like joules or Newton. They don't want it, they want it in terms of this. So how do we convert? I'll show you the next one. Now, examples of derived quantities. So let's look at the definition. So derived quantities are quantities that are obtained through the product and quotient of other physical quantities. So product means you multiply. Quotient means you divide. Means you multiply or divide other quantities and you get a derived quantity. Example, like density. What's the definition of density?
Mass or volume.
Mass per unit volume. That means you take the mass, you divide by volume, so it's quotient. Right? So it is a derived quantity. Now another example is, let's say, force. How do you define force? The definition is rate of change of momentum. That means change of momentum divided by time taken. So you express in terms of other quantities, right now, and you divide, right now. So the SI unit for force is Newton. That's called SI unit. But they want you to be able to change to base SI units. So base SI unit, I don't want Newton. I only want in terms of the 6 units: kg, m, s, Kelvin, ampere, mole. So how do we do it? So I teach you the technique to change your unit into base SI units. So don't confuse base SI units and SI units not the same. SI unit for force is Newton, but base SI units only have kg, m, s, and all those things. So the technique is, what you will do is first you write down the formula. Okay, so let's say you don't remember the formula for force, which is rate of change of momentum. Because most people, they remember F equals to MA, their favorite formula. So you can, any formula will do to find the unit. So you square bracket it. Square bracket means the units of. If you don't square bracket, then you cannot change your M and A into units. So you square bracket it. So what's a unit? Base unit for mass?
kg.
Kg. What's the base units for acceleration? Meter per second squared. So you multiply, so the base SI unit for force is kg ms negative 2. Now same thing you would do, for example, like work done. So work done, what's the formula? Force times distance. So you take force times distance, so therefore the bracket, square bracket means the units of W. So you substitute the unit for force, kg ms negative 2, you substitute unit for distance, meter, and you get the base SI units. So everything also can change the base SI units. Do you understand?
Yeah.
So now let's say we want to do another one which is power. So we want to find the base SI unit. So the first step is to always write down the formula. So what's the formula for power?
WD?
No, it is energy per unit time or work done per unit time. So let's say we do work done per unit time. So the units of power, square bracket. So work done, which is kg m squared s minus 2 over the time, which is seconds. So then you will get kg m squared s minus 3. So every formula also can do like this. So what is the SI unit for power? Watt. But what's the base SI unit? Kg m squared s minus 3. Alright? Now there's also one more part here called dimensions. Now dimensions are not strictly in your syllabus, but we just mention it in passing so that at least you understand what are dimensions. So you notice that every single of these base quantity which has a base unit has a dimension. So basically dimensions are only for those base quantities that have your base units. So sometimes they will say that a constant is a dimensionless quantity, or a quantity is dimensionless. So what does it mean? It means that it has no base units. So can a quantity have a unit but cannot be expressed in base units? That's the question. Can. For example, angle. So example of a quantity that has a unit but no base units will be an angle. Now let's say this is a circle, center of circle. So this is the length of the arc. Let's call it S. And this is the radius, R. And the angle is called theta. Now in your additional maths, you have learned that the definition of angle in radians is the ratio of length of the arc to the radius. So then you get your unit as radian. So since your angle in radians is given as the length of the arc divided by the radius, and your unit is radian, let's look at what is the base unit for S, length. What's the base unit for length?
Meter.
What's the base unit for radius?
Meter as well.
Meter also. So both also meter. So when you divide, what do you get?
Meter.
Nothing. No unit.
Okay.
Therefore, radians has no base unit. So it has a unit. There's a unit called radian, but it's dimensionless. That's all we're trying to say. Okay? So next thing we're going to learn is called homogeneity of physical equations. So what is homogeneity of physical equations? So let's talk about physical equation. A physical equation is any equation that you can think of in physics. So it's called physical equation. And most of the time, students will tell me they will always remember which physical equation? The kinematics equations. Example of a kinematics equations, let's say we use S equals to ut plus half at squared. Is this an equation in physics? Yes. So it has to be homogeneous. Homogeneous means the base SI units on the left hand side must be equal to the base SI units on the right hand side. They must be the same. So homo means same. So they must be same base units. Example, I prove to you. So let's say I want to test whether this equation is homogeneous or not. So I will start off with left hand side. So what is the base unit for S? S is your distance, right now. So what's the base units for S? Meter. So right hand side. What is the base unit for UT?
Meter.
So it's meter per second times time, which is second. So you will get meter as well. And then on the right hand side, you have half AT squared also, right? Now you remember you cannot add these two base units. Units don't add one. You cannot take like meter plus meter get 2 meter. So you every time there's a plus or minus, you treat them separately. So you treat UT separately, you treat half AT squared separately. But when you treat half AT squared separately, half got unit.
No.
It's a constant. Ignore it. You only write their units only. A, what's the unit? meter per second squared. And what's the unit for time?
S.
Second squared.
Mm-hmm.
So you end up with meter. So are all these base units the same?
Yes.
So you would say, since left hand side is equals to right hand side, the equation is homogeneous. That's how you would write your conclusion. Now, every physical equation is homogeneous, but not necessarily all equations which are homogeneous are physical equations. What do I mean? If you tell me there's a equation in physics that you know is correct, that I can tell you is definitely homogeneous. But you cannot plug any equation that you want from the air, and just because it's homogeneous is correct. I give an example. Now let's say some students remembered this formula wrongly and put that s equals to ut plus 2 at squared instead of half. Is that a correct equation? No. But will it be homogeneous? It will still be, because you will ignore the units here. So not all equations which are homogeneous will be necessarily physical equations, but all physical equations are definitely homogeneous. Alright? And we can also use homogeneity to find units of unknown quantities. Let's say they give you an equation and they tell you it's homogeneous. Let's say you know this equation is homogeneous, but you didn't know what's A. What is A? So you don't know what's A. You can use homogeneity to find out the base units for A. Then you can find out what is the quantity of A as well. So there are many uses of homogeneity. For example, let's look at June 2002, paper 1, question 3. The question asks which formula could be correct for the speed v of ocean waves in terms of density, acceleration of free fall, depth of the ocean, and wavelength lambda. Now, if you look at the options given to you, most of these formulas are unfamiliar, probably because most of them are wrong. So how do you find the correct answer by not knowing any of these formulas? We can actually solve it by using base units. Since the formula is for speed v, and v has a unit of meter per second, so what we have to do is we have to do try and error for each of these options and find the units on the right hand side, see whether or not they give us meter per second. So like for example, the first one, which is the correct answer, square root g times lambda. So what is the unit for g? Meter per second squared, because it's acceleration. Lambda is in meter, so square root is power half, and then we end up as meter per second. So that is the answer. But if you to try option D, you will notice that g will be meter per second squared, rho is in kilogram per meter cube, and then square root is power half, and we in the end we will not get meter per second. Alright, so we can use base units to find a correct formula. And this next question, which is November 5, paper 1, question 3, they ask you to find the expression which gives that gives the base unit equivalent to the volt. So the formula for volts, which is actually like PD or EMF, is given by this equation, V equals to W divided by Q, where W is energy change and Q is charge. So therefore, if you want to convert this into base units, so the base units of V, so the square bracket means the base units of V is, so W is energy or work done, so that's kilogram meter squared S minus 2. Q is equals to IT, so you change it to ampere second. So in the end, we will get the base units of V as kilogram, m squared A minus 1, S minus 3. Alright, for this example, June 12, paper 21, question 1, let's go through the question. So first they said, first they ask you for the base units for volume, so that's straightforward, meter cube. Then they ask you for the SI base units of pressure. Now, whenever they ask you to find the base units of a certain quantity, you must start from the formula. So any formula for pressure will do. Like for example, P equals to F over A is okay. P equals to rho GH is also okay. Alright, any formula for pressure will do. So let's say I start with this equation, P equals to F divided by A. So the units of P equals to units of F, which is kilogram meter per second squared. divided by the unit for A, so that's the formula, that's the units of P. So for the next one, which they ask you to find the base units of C by giving you this equation first. So what do is you make C as a subject, okay? So whatever they ask you to find, you make it as a subject, so you will get this equation. So once you have this equation, you can substitute all the units for the quantities here. For example, P pressure, and we should obtain from here. R is radius, which is meter. So R to power 4 means meter to power 4. T is time, which is in second. L is length in meters. And V here is volume, so it is in meter cube. So after substituting all and solving it, then you will get the units of C. Right, our next question is June 13, paper 12, question 2. They gave you the expression in terms of base units for resistivity, and they ask you to find what is X, Y, and Z. So for this question, what we need to do is to write down the formula that has resistivity, which is R equals to rho L over A, where rho is your resistivity. You will find this formula in the topic of current of electricity. So since we want to find the units of resistivity, we shall make it as my subject. So rho equals to RA over L. Now, the resistance here, which is the unit ohm, is not a base unit. So I will need to convert the resistance in terms of ohm to base units. So for that, I will use another formula for R, which is V divided by I. So therefore, the units or the base units of R will be the base units for V, which is W divided by Q, that means energy per unit charge. So these are the units for energy, and charge is Q equals to IT, which is ampere second. All right, and then I here is ampere. So this will be the units for V, and this will be the unit for I. So you will get the units of R as kilogram m squared A minus 2 S minus 3. So for which we will substitute into this equation. So for R, so bring it in, and then A here is area, so it's meter square. So therefore L will be meter. So after solving, we'll get this, and by comparing these two, we will see that Y is actually A ampere, Z is actually S, which is second, and X as M. All right. Right, our next example is November 10, paper 21, question 1. So the first part is quite straightforward. They just ask you for 3 other SI-based quantities other than mass and time. So you can write any of these. Now remember, luminous intensity is not in your syllabus, but it is a base quantity, so it's not wrong to write it. Okay. Next one, they give you an equation and they ask you to state the SI base units for F, rho, and V. But they did tell you what is F. F is resistive force. Rho is actually the density, and V is actually the speed. So therefore, to find the SI base units, you can straight away write them down. If you forget, go back to the formula. For example, F equals to MA, rho equals to M divided by V, and V is this rate of change of displacement. Now, after you get all these 3 units, then after that they ask you to find the value of K, all right, from this equation. So remember, homogeneity of physical equation, the units on the left hand side must be equals to the units on the right hand side. So the units of F here is actually kg s negative 2. Then the units for B r squared rho V K. So they did tell you that B and K are constants without units, so you don't have to write the units for B. For R is in meters because it is radius, so it's meter squared. Rho is kilogram per meter cube. V is meter per second, power K. So what you need to do is then to expand all of this and combine the expressions for M and S together. Because kg is by itself, but for M, can you see the M squared and M negative 3? So 2 minus 3, you get negative 1. And then don't forget there's a M power K, so it's negative 1 plus K. As for S is just power of negative 1 times K, so it's power of negative K. Then by comparing this expression to the one on the left, we'll notice that kg and kg is the same. Then you look at the power for m here. The power for m here is -1 plus k, and the power for m here is 1. So -1 plus k equals to 1, so k equals to 2. Then you can also compare the power for s. So here s is power -k, here the s is power -2, so -k equals to -2, so k equals to 2. So whichever one you use, either the power for m or s, you should get the same answer.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.